Hey guys, so today we're going to talk about shifting a parabola on the coordinate plane, and we want to focus on two things when working with quadratic equations. We want to work with the vertex form, which is y equals a x minus h quantity squared plus k, and then we also want to translate the vertex point, and this is something we can easily get when the quadratic equation is in this form. So let's focus on the parent function of a quadratic equation. So if we were to compare the parent function and the vertex form, we would see that the parent function is pretty empty. There's no visible a, no visible h or k. So this has no transformation applied to it. And the graph of that would look like this, where the vertex point is 0, 0. Now let's say we want to do a horizontal shift 2 units to the right. Well, we want to translate the vertex point. So what would 2 units to the right of this vertex point be? That's going to be 2, 0. So let's plot that here. And that's 2, 0 here. Call that 2. Okay, so we have our translated vertex point. Now what will the equation look like? So as you can see, there is no h and k value. That's why the vertex point here was 0. But because we now have translated and applied the h to it, our h value is going to be a positive 2. So if we substitute positive 2 into the equation for h, we get y equals, we didn't do anything for a, so let's just leave a as 1. It's going to be x minus 2 squared. And there's no k value, so we're going to leave that as 0. Now, if you're having doubts as to why it's x minus 2 and not x plus 2, let's check this out. So if you look into your graphing calculator, you want to press the y equals button. First, write the parent function, which is x squared. Then you're going to write the new equation. So in this case, it's x minus 2 squared. I'm going to darken the line for this equation so I can see them both clearly. And I'm going to hit graph. Now my parent function is showing, and I now have my second equation, and I see that it has moved 2 units to the right. And of course I can also look at the table of values to compare how the coordinate points shift as well, but I just want to focus on the graph. Alright then, so let's move on to doing a horizontal shift 2 units to the left. So if I'm moving 2 units to the left, I can take the original vertex point, which was 0, 0, move it 2 units to the left. That puts me at a negative 2, and the new vertex point is negative 2, 0, and my parabola now looks like this. And if I want to show that on the graph, let's see, I can do a plus 2, right? Because I moved negative 2. If I were to substitute in here, this would be y equals x. Since I'm doing negative 2, it's minus negative 2. That turns into a positive squared. And on the calculator, it should give me that graph shifted over to the left. So here I'm graphing. Here's my parent function. And now here's my translated function 2 units to the left. Alright then, so let's go over to where we have vertical shifts. So we want to shift 3 units up. Okay, when we did horizontal shift, we affected the x-coordinate of the original vertex point. So of course now we're going to affect the y-coordinate. So if we're doing 3 units up, this 0 turns into a plus 3. So our new parabola is going to look like this, a little shifted up. It's going to be 0, 3. Now what would the equation look like? Well, since we're not affecting the h is still remaining 0, it's just going to be x squared plus that value. So in this case, our equation is y equals x squared plus 3. So let's see what that looks like on the graph. So I'm going to delete this, and I'm going to write x squared plus 3. And I'm going to make sure that I change this so I can distinguish. I'm going to graph. Here's my parent function. And now here's my shifted function up 3 units. Okay, great. So let's do the next one where we're shifting 3 units down. So again, we're affecting the origin. Our point's going to be here, 0, negative 3. We just have our parabola looking like this. And if we want to verify on the graphing calculator, we can just do minus 3. Graph that. Parent function. And now 3 units shifted downward. Alright then, last but not least, and something that you'll definitely see commonly on the Regents or any other big exam, is a combination of the transformations. In this case, we're just working with translations. So here, we have a horizontal change of 3 units and a vertical change of -2 units. So let's see what that would look like. If I'm doing a +3 change and a -2 change, my coordinate will be +3, -2. So my graph should end up in this region. So +3, -2. It's going to be facing up because I'm not changing anything else but that. And then if I were to try and figure out what the equation would look like, it will be y equals, now I'm affecting both h and k. So a equals x, it's going to be -3 squared, and it's going to be -2. So let's see if when we graph it, it puts us in that situation. So I'm going to erase this. It's going to be x -3 squared, and it's going to be -2. I'm going to change that. Oh, didn't mean to do that. Well, as you can see, there are clearly more options, but you only need that one. So graph that. Should be in this region. Okay, perfect. So you see it lines up with the 3 and the -2, and our equation does match what we put in the graphing calculator. And that's pretty much it on sketching and shifting parabolas in general. So if you have any questions or comments, leave them in the comment section below, like and subscribe, and of course I'll be making more videos on parabolas and transformations. Alright guys, bye!